Number 15, kind of an amazing story about how petroleum economies are so explosive.
You mean 17?
Yeah, that's what I meant. 17, an interesting story about dynamic petroleum economies. But I want to talk about 18 and 19 now. Please look at my wacky ass drawing. I'm going to use this drawing repeatedly, and there's a bunch of words that you'll have to define on your papers that I did not define here.
You want us to draw this?
Yeah, probably. Here's some things. I believe when you were in the 7th or the 8th grade, you must have had some basic earth science stuff that talked about the rock cycle, where rocks are exposed to erosion, and then gravity carries that sand down to the ocean where it'll deposit and turn into rock. We call that sedimentary rock. Raise your hand if that sounds vaguely familiar. Now, if you needed to pick apart some of those words, please look up. Erosion is when rocks are broken down. That can be with wind, that can be with rain, that can be a chemical process. Sometimes when water freezes, it expands as ice, and so there's a type of erosion which is from water expanding when it makes ice. But the part that you would need in your definition now is the simple part. Erosion is when rocks break up. And if you knew that, you don't have to write this. You probably don't have to write this, but there's these things called clouds. And sometimes they cry. We call that rain. It's angry crying.
Why's the cloud sad?
This one's angry, actually. Angry crying.
Is it because it didn't
Shut the
get
fuck up,
evaporated?
Yes, yes. This cloud is very angry, sad because he's hangry. I can sympathize. Can you imagine if everybody just fed me burritos? That would be so cheerful all day. I'd stop being grumpy and I'd stop saying shut up and I'd stop making fun of your moms.
Your mom, I had.
That's good.
Don't even.
Manipulate his head. Oh, he's getting angry. Alright. So rain causes that erosion. You can see the water flows downhill. And that's going to make deposits. A deposit is just where stuff piles up. Here's a vocab term for you. A depositional basin is like a low spot where things are going to deposit. There's a few people here who are very familiar with a harbor, like the Santa Barbara Harbor, where the water slows down, everything in the water deposits. So any place that slows down water, technically narrow bays are depositional basins, because once the water gets in there, it's not moving as much, so everything will settle down. You can tell you're in a depositional basin because the water tends to be more clear. Because it's not moving, the solids all went to the bottom. So a depositional basin is where stuff settles. That's called a deposit. And here's something that you probably didn't have this word before. That sand, because of heat or because of pressure or because of chemistry When it turns into rock, there's a word for that I need you to know. That's lithification. That may be hard to read. How many of you are struggling to read that? I'm going to try to rewrite it. Maybe this marker works better than the last one. That was very carefully written. Lithification.
Well, I'm proud of you for that.
Thank you. What you get when a bunch of sediment turns into rock is sedimentary rock. Honestly, all these words are not supposed to be the tricky part of this explanation. I just want to make sure that we're all okay with these words. Can I move on, or does everyone want to ask me about these words? Yeah, moving on. Okay, here we go. Now, rock stuff happens all the time. That's just rock stuff. So when you look on the planet, all the continents are rock up in the air, and there's clouds and wind hitting all those continents. So everything above sea level is getting worn away and becoming rock again below sea level. Right? Conceptually, you all understand that all the continents are rock which is doomed, and all the sea bottom is rock which is growing. Yeah? Every now and then, you capture some organic material in there. Like some fur off my weird monkey, like some leaves off my wacky tree, some seagull droppings, and some dead ants, and some little pieces of grass. Those will be carried by water down to the ocean. And hold on a second. What happens to all of the dead tidbits of leftover organic material at the bottom of the ocean? What happens to all that stuff? Yeah. Most of the time it doesn't. Most of the time, what happens to it? How?
Fish.
Yeah. Most of the time it gets recycled back into life. If I take Evan Facenda's skinny little corpse and I throw it over the fence onto my hillside, I guess we all laugh. I'm sorry, Evan. That wasn't supposed to be the funny part. I would cry. Bronze not laughing. If we take Evan's lifeless corpse and we throw it over the fence onto the hillside, you know, like other critters are going to come pick through that, and actually Evan Facenda will probably be other wildlife by tomorrow, the day after, the week after. Evan Facenda would get recycled into butterflies and wildflowers or maggots and rats or something. Do you all know that when leaders in Buddhism, when lamas die, there's a special group of priests whose job it is to tear apart their body into little pieces and take them up to a hillside? It's called mountain burial, where they don't actually get buried, they just take the dead person's little chunks and they throw them into the air to feed vultures. How many of you had heard this? I do. I would love that. The whole idea of like accelerating the recycle thing.
Plus, it's not like you can feel anything.
Right. Actually, I wouldn't care what happens because I'd be dead, so I guess I don't really care. But maybe when somebody else dies, I'd like to do that.
Should stop those.
That sounds weird too.
We should stop Jose and then just put him up here so whoever has this classroom can just have Jose there the whole time.
Just a taxidermy of Jose.
Yeah, exactly.
Have you guys seen that bronze statue on the way to the mission of the dog that died in the fire, or that didn't die in the fire, that rescued its owners from the fire? died of old age, and so they turned the dog into a bronze statue on the front lawn?
That's
Yeah.
really cute.
They put the dog in.
They have to dress it up for.
Wait, they put the dog in the statue?
No.
No.
Oh,
But
wow.
that was the old rumor.
I
went
see.
to the school next to
They
it.
just poured brass over the dog.
Wait, so this whole thing about like the stuff getting recycled, can you say one more time how it relates to like?
Yeah.
I kind of forgot what you said.
Right. What the hell are you talking about, Jose? Here we go. I need to point out that organic material doesn't usually get trapped in rocks because organic material is useful. Like if you throw away something expensive in the waste stream, it probably won't make it to the landfill because somebody's going to pick through that and take that expensive thing out. Biomass is useful, ecologically speaking. Evan Facenda's body won't become fossil fuels because Evan Facenda's little bits will get used up by the larvae of flies or by worms and crabs in the bottom of the ocean. He's not going to become fossil fuels. What's required to make fossil fuels is these really rare events. Almost always fossil fuels don't happen. You should remember that organic material is about 99.9% always going to be in life. You're made out of stuff that was something else, that was something else, that was something else, that just keeps getting recycled.
Is that why biofuel is so efficient?
Yep. Now, it's extremely rare, but maybe something that can happen is a whole bunch of organic material can be trapped by a thick layer that's inorganic. Like if Evan Facenda's tidbits get down to the harbor and all of a sudden there's a huge mudslide that buries that, now the crabs and the worms can't reach the tidbits of Evan Facenda.
Goes into our cars.
Then in a couple million years, we're going to put them in our cars. Those rare events, please look up. You may want to know these. That's like flood or volcano or this trigger alert. I don't want to hurt anyone's feelings. We actually had one of these. I've been saying the same thing for like 17 years, but now it's a touchy subject. You know, like if there's a really big fire and then there's a bunch of rain and you get a flood of ash. Like you have lived through one of these rare events now. If all of a sudden there's these giant floods of material coming off land, maybe some organic material gets buried under so much inorganic stuff that you've like trapped a little bit of biological material and kept it away from other biology. Everybody good with this? This is why we say that fossil fuels, please look up, are imperfections in sedimentary rock. It's like a stain of like organic stuff in the layering of rock. Anybody ever open an old book and find like a dead fly or something? That's fossil fuels. Yeah, nobody reads, right.
Silly
That
boy.
flag from the pictures in my Kindle.
Why is that fossil fuel?
Because it's like, it's not normally there. Organic stuff is not usually trapped in rock. Rock is usually just sand and all the organics get filtered out of sand. If you go snorkeling in the harbor, which I probably wouldn't recommend, there's a whole bunch of stuff on the bottom of the harbor that's eating the organic material.
Yeah.
There's like hella little crabs and little worms, and I don't know what the hell's down there that eats all of the organic material. There isn't usually organic material left in sand. It's like people who walk through the dump to take out all the valuables, same thing. There's like stuff on the bottom of the ocean that takes out all the valuables. But every once in a bazillion years, you get a giant flood, you get a volcanic eruption, You get like a mega fire followed by a mega rain.
I'll say all deposits are mixed.
Yeah. And so fossil fuels are imperfections in sedimentary rock, which is extremely rare. It's not that common. Stop what you're doing. Get a quick little visual. That map of the Earth is 100% rock from left to right, top to bottom. You all realize that's rock, right? Like from the top to the bottom, it's either rock under the ocean or rock on land. That's all rock. There's a little bit of dirt on top. And all that rock is basically just rock. All the way down to the red hot magma. It's rock all the way down. It's rock all the way down, except for a couple of little stains in the rock, like a little smear of petroleum in one spot, or a little fizzy pocket of natural gas in one spot, or some weird slimy rock that we call coal. But those are rare. And what happens in those deposits is like this. How many of you thought I had a stupid warm-up? Well, I think you're stupid, but I can show you why I use this warm-up. Please look up. Please look up. Jose has a pillowcase full of Legos. So many Legos. And I'm going to zip up or sew up my pillowcase so now they're sealed. And please look up. I'm going to massage that pillowcase. This is how you massage. I am an expert in the art of massage. And so I am massaging my giant sack of Lego. If I kept going like this, with a pillowcase full of Legos,
All connect eventually.
for like eternity, like 100 million years, imagine how tired I would get
Burrito.
of massaging these. Yeah, just keep fueling me burritos and I'll keep massaging your Legos. That sounds marginally inappropriate, huh? But I'm just being spontaneous here. I just massage my Legos and you feed me burritos. We're good. Eventually, like Homeboy says, they're all going to start to click together. Every time you squeeze a bag of Legos, you're going to go like click, click, and make like 2 connections. And then you squeeze it again, and there's going to be a couple that are just lined up enough to go click, click, and they're going to connect. Agreed? So if I just massage the F out of this bag of Legos until Kingdom Come, I'll probably have like a giant blob of Lego. And it's not going to be like a Millennium Falcon or like a castle. It's just going to be like a big random connection of Legos. Well, there's almost no loose parts left, right? That's what fossil fuels are. Because look, in here, we have organic material. This is basically just little cellular trash. It's small. So it's micro life, like cellular trash. But there's like sugars in there. There might be some fats in there, some oils. And all of that are hydrocarbons. Does everybody understand my writing? Some number of carbons stuck to some number of hydrogens stuck to some number of oxygens? Don't understand that? Those are integers. So that's what we call hydrocarbons. And there you go, those are the little Legos. You squeeze them all together and you get big old carbon chains. Get ready for this crazy thought. Some of those carbon chains are going to be so short that it's like 1 or 2 or 3 or 4 carbons stuck together. If there's nothing else on that, it's called natural gas. Natural gas is just a really short carbon chains. And some of those carbon chains, if they're really, really, really long and they're relatively pure, that could be liquid carbon chains. That's what we call petroleum. And if there's long carbon chains with a bunch of other atoms connected, like a bunch of other stuff that makes them not be runny, that's what we call coal. Fossil fuels are imperfections in sedimentary rock that are rare, that contain chains of carbon bonds. And the gas, the liquid, and the solid are all mixed. Every deposit has all three. Every deposit has all three in differing ratios. It could be mostly solid, we call that a coal bed, but there's some petroleum and gas in there. It could be mostly runny, we call that a petroleum deposit, but there will be some coal and some gas. Or it could be a natural gas deposit, but there's going to be a little bit of petroleum and coal in that. Yeah.
In organics, what is the second thing downside?
Which is cellular trash.
Cellular?
Yeah, cellular. Like little bits of, it's not like bits of life like a forearm. That's a fossil. I'm talking like a cell burst and then like some sugars and some fats of that cell. That's the level that we're looking at. So this is microscopic organic stuff. Okay, I want to tell everybody a little story. Yesterday I came home. My wife says, here's the shopping list. I said, okay. I go to the store and I buy some groceries. Park on the street, take my bag of groceries, walk across my front lawn, trip on the hose, throw my bag into the air on my way to the ground. When all that stuff goes into the air, a carrot tears a hole in my bag of sourdough.
A carrot?
Shut up. My chainsaw tears a hole in my sourdough. The sourdough spontaneously erupts.
Did you go shopping for chainsaws and sourdough?
Yeah.
I respect that.
Then my jar of peanut butter smashes into my jar of jelly.
Yeah.
And as I'm going to the ground, I stumble, catch myself, reach out, and I catch a peanut butter and jelly sandwich that spontaneously formed in the air by my giant accident. How many of you believe my story? That's about as likely as this story. I need to emphasize for like the 7th or 8th time
Pizza Rock.
that organic material doesn't usually end up being fossil fuels. Fossil fuels are really, really rare. You could just randomly look through the crust on the earth and never find fossil fuels. They're not common. Of all these books, there's probably only a couple of flies stuck in the pages. It's really a pretty unique circumstance. And so there's names for the rock that makes these deposits. You have to know a few words, not all of this. Get ready to write. Source rock is fine-grained and quote-unquote the base of the sandwich. It's like the bottom stuff. When you squeeze it, it compacts pretty easily into rock. It was almost rock already. It's what made up the depositional basin. So fine-grained is the key thing for you to know. It's often organic rich. It's the base of the deposit. And then you're going to give it a bunch of heat and pressure. So basically anything organic is going to rise out and that's going to turn into rock. You can see it in the picture. It says source rock right there. And in the middle of the sandwich, you have this coarser rock. I need to give you a visual, and it's important that we're going to come back to this a lot. A fossil fuel deposit is not like an underground chamber. I think there's a movie called Ghostbusters 2 where the ghosts show up in New York City and they go like into these like big sewers underground, and so there's this image of them like digging through the ground and they pop out in these huge underground bodies of like slime or water or something, I can't remember. Humans visualize that like when you're digging for petroleum, you're gonna hit like this big buried chamber of petroleum. That is incorrect. It's rock with like stains on it. If you want a good visual, imagine a 5-gallon bucket with a bunch of gravel stirred together with peanut butter. That's petroleum. It's rock, and then in the spaces between the rock, you've got some sticky stuff.
Is the peanut butter the rock or?
That's the fossil fuel. So the gravel would be the reservoir rock.
But how do people like drill for it to like fish?
That's exactly the correct. So Homeboy says, how do people drill for that? 2 slides and I'll show you. The thing I want to be really, really specific about in your notes, remember, the reservoir rock is not like a chamber. It's just like rock where the fossil fuels are in the pockets. And that would all leak to the surface if it's not sealed in by a third rock called cap rock. Why is this image usually like? all the other organic material that goes into the ocean becomes life. Human stuff gets recycled, plant stuff gets recycled, dead fish get recycled, Sam's cell phone gets recycled. Anything that makes it to the bottom of the ocean gets recycled. Unless it's caught in this one weird sandwich of rocks, this weird combination. And if it does, we can take it out. Please look up. Even in this picture, the oil and the gas are like a separate reservoir. That is incorrect again. This picture is misleading. Like the best images are this one. See how there's just like pockets where the rock is a little bit richer with stuff?
How do they drill?
Where's another? Like that. You see how the oil and gas are just in the spaces of the rock? Let's go drilling for it. This is called recovery. Recovery is when you take out the petroleum. We say that there are primary, secondary, and tertiary extraction, or primary, secondary, tertiary recovery. And petroleum goes like this. A little bit comes out very easily, then you got to work hard for it, then you got to work really hard for it. I have an easy analogy for you. When you open a fresh tube of toothpaste, sometimes a little bit comes out on its own. Like your first night of toothpaste, you just like peel off the aluminum thing and it's like, whoa, free toothpaste. And you get like that one little toothbrush worth for free up front without having to work for it. And then you got to start squeezing the toothpaste. That would be secondary extraction. And then you got to get all like crazy about it, like rolling up the bottom and like sliding it over the corner of your counter and use like your fingernails and like squeeze and deform to get that last little bit out. That's tertiary. And now you're going to need some notes. Primary is when it comes out on its own. Like when you first take the foil off the toothpaste, it will literally just go, and like a little bit's going to shoot out. Like popping a zit. It's under pressure. It's just barely kept in there. So when you make a hole in the top, it'll just like come out on its own. You like the popping a zit visual? Everybody's favorite? If you've ever seen some movie from like Texans like 70 years ago with like the oil rig and they like drill a hole and it shoots out of the ground and they're like, yee-haw! And they all like throw their cowboy hats in the air and they're like getting rained on and they're all going to be president?
Sure.
That's primary extraction. Wait, somebody's parents? Whose parents? Somebody say my parents? Oh, I thought somebody said like my parents.
Right. What is the recovery rate?
Recovery rate is how much was down there, you know, like, hey, let's go back to my visual. If I've got a 5-gallon bucket of gravel with peanut butter in it, and I make a hole in the lid, the gravel's going to settle and some of the peanut butter's going to squeeze out, all you're getting is a little bit of that. That's what recovery rate is. You're only taking about 5, 10, maybe 15% of the petroleum under its own pressure. And then the rocks settle and most of it's still left down there. That make sense to everybody? Almost all the petroleum that you've ever seen came out in secondary production. where you inject water. Look at me. Raise your hand if you've driven by the freeway and seen one of these things. Almost every single one of those that you ever saw was not taking petroleum out. It was pushing water in. Can anybody imagine why you'd want to push water in?
Push the petroleum.
Oil goes up.
Oil floats on water. So in all those little spaces between the rocks, you're squirting in water, and the water's sinking between the rocks, and the oil is floating out somewhere else. Like our rigs out here, that's what they do. When you go by the rigs on a boat, they're like, and that's just like salt water getting pumped under the rocks. And then in one of the rigs, there's a pipe open somewhere that lets the petroleum rise out. As a matter of fact, the ones that you see down by Rincon, Little Rincon, are they off Little Rincon? Who serves? You serve? Is that Little Rincon? Like that little island, Arco Island.
Yeah.
Yeah. The ones that you see by Little Rincon, there's like 4 rigs way out there. Those only compress. All the petroleum comes out on land. The rigs are just injecting water. And then all the petroleum is getting pushed out on land somewhere. As they're all pumping in water, it just goes, it comes out on land somewhere. Yeah.
Is there like a difference in quality in the?
Yeah, absolutely. Because now it has salt water in it. Now it has sand in it. Now it's like slimy and dirty. Yeah.
Isn't it bad for us to be pumping salt water like into the earth?
You know, like gravity's already putting salt water into the earth somewhere, so I'm not too worried about that. But separately, where that comes out, now you've got nasty salt water that's all slimy because it rubbed against oil and coal and stuff. So this is a really ugly process. Notice that we're still getting just a little bit of the petroleum. Yeah.
How do they know where it's gonna come out in the ground?
Little people with hard hats.
How little?
We take high school girls that ask too many questions and we make them go down there. I don't know, dude. I think there's like engineers and science.
One question I have.
I know that over the years, a lot of my students go study environmental science and geology and stuff, and they all end up working in this. It's like the one place where everybody can get a job. Because there's always more, and it's so much money. Look, most of these are injecting. One of them just lets it out. So you build up pressure with water, and then you go boom, and you like let all the petroleum out. And then you build up pressure with water, and then you go boom, and you let all the petroleum out. When it comes out clear, you got all the easy petroleum. And then, if you can afford it, you add heat somehow. Hot water or even steam to make the oil runnier.
So there's no way to actually get like all of the petroleum.
Yeah, exactly. Most of it's left down there. And we're going to talk about that in a minute. Maybe we'll talk about it on Monday. I've got a fascinating picture that I've been waiting to show you guys all year. I've been using it as my bookmark. Who knows the Mesa? Mesa Rats Unite? Look. From the top of Flora Vista, looking down at Monroe, across Cliff, down Mesa Lane. From the top of Flora Vista, looking down at Cliff,
Oh, that's so.
into the distance is Mesa Lane. So,
That was Douglas. Douglas.
this is Monroe. That's the Douglas Family Preserve. That's Cliff. This is where Flora Vista has that stagger to Mesa.